Number 22, solve the problem, and we're told the number of women attending a conference was 3 less than twice the number of men. If 51 people attended the workshop, how many were women? All right, fair enough. Now, in word problems, normally we're used to using the variables x and y to represent our unknowns, but because this is a more real-world application, let's go ahead and let w represent the number of women, and we'll let the variable m represent the number of men, right? You could use x and y, that's perfectly fine, but in this case, it might be easier for us to see w and know right away what w represents, m, we know what m represents right away. And so we're told that a total of 51 people attended this workshop. So we know that the number of women plus the number of men would have to equal the total number of people that attended this workshop. But let's see if we can use the word problem to either rewrite this w in terms of m or this m in terms of w. So what does that mean? Well, right now we have two variables. We have a w and an m, but only one equation. So we want this whole equation to be all w's or all m's so that we can solve. And if we go back and we look, we see that the number of women, so in this case we're talking about this variable, the number of women attending was 3 less than twice the number of men. All right, well, how would we represent just this part of the word problem? So off to the side, how would we just represent 3 less than twice the number of men? Well, twice the number of men would be 2m, and then 3 less than that, we could say minus 3. So what we're going to do is we're going to say this little expression here equals w, right? Because we're told the number of women, so, and again, w equals the number of women, was 3 less than twice the number of men. And so now that we've got this little expression to represent how many women attended, we can take this expression, plug it into our equation where we see a w, and then the whole equation will be in terms of m. So if we say, all right, take out this w, put in 2m minus 3, and again, this is the number of women, well, plus m, that didn't change, equals 51. Now we can combine like terms here on the left, so 2m plus 3m, or excuse me, 2m plus m gives us 3m. I was jumping ahead of myself there. Minus 3 equals 51. We want to solve for m, so let's add 3 to both sides. And we end up with 3m equals 54. I'm going to carry this over here. So 3m equals 54. Our last step will be to divide by 3 on both sides, and so we get m equals 18. So because we were using w and m to represent women and men, we know that m equals 18 means that 18 men attended this conference, this workshop. But recall what we talked about in class. With word problems, you want to go back to the original question, or rather the original word problem, and see what it is specifically that they're asking us. And that usually comes in the last sentence. And so they tell us, if 51 people attended the workshop, how many were women? Well, we just solved for m, for men. So this is not our answer. This tells us how many men attended the workshop. We want to know how many women were in attendance. So you could do one of two things. You could either say, all right, well, I know 51 people total attended this thing, and if 18 of them were men, well, I can say 51 minus 18 gives me 33, which means 33 women attended. Or you could take your value of m, which was 18, and plug it into this equation that we created earlier to solve for w. So we would say 2 times m, the number of men, so 18, minus 3 equals the total number of women. And in this case, we have 36 minus 3 equals w. And so 36 minus 3 is 33. So again, either way, whether you go and say, all right, 51 minus 18 is 33, or you take your value of m and plug it in, we still end up with the same answer. And so for number 22, we end up with 33 is the number of women that attended this workshop.